Earth scientists are presented with big questions. Questions that range from the bottom of the ocean to the tops of the mountains, from polar ice sheets to desert sands, from a moment in time millions of years ago to a future that's far from certain. At Stanford University, faculty and students in the earth sciences grapple with these big questions. What can we learn now to prepare for a changing future?
I was astonished to discover that we don't know how long the Antarctic ice sheet has been in its present stable form. We don't know how long that blanket of ice has existed the way it does, and we don't know how sensitive it is to changes in the global climate. And that was astonishing to me. That was a mystery I could really sink my teeth into.
We're also working very hard to discover how fast it can melt when it does melt. Does it happen in a century or does it happen in 500 years? And those are multiple billion-dollar questions for understanding how we're going to adapt to future changes on the planet.
What knowledge can we bring to bear to help mitigate the risks of natural hazards like volcanoes and earthquakes?
Well, here in the SAFOD project, we're doing scientific drilling into the San Andreas Fault at 3 kilometers depth where small earthquakes are occurring. The purpose is to study the physics of faulting, what actually happens inside an active fault as earthquakes are about to happen, as they happen, and what happens as the earthquake kind of comes to a stop. It's never been done before, and it's been quite a challenge.
Stanford researchers are also training the next generation of earth scientists.
The rules that we're using here again are those very simple ones that we learned, that layers are laid down flat, and if they're not flat anymore, something happened to them.
We're also working on better understanding the impact our current choices will have on the centuries ahead. How can we sustain the most basic human needs for food, water, and energy?
A very important question we have in energy resources engineering is how we should best optimize our current energy resources. And to answer this, we develop very advanced computer modeling techniques that we can use to accurately simulate oil and gas flows in reservoirs. Now, we really need to have a diverse energy portfolio and not just rely on fossil fuel resources. So we're also very excited about some new research projects that use, again, modeling techniques to study optimization of wind and ocean resources. The challenge really will be to develop sustainable worldwide energy resources that meet the needs of society, but at the same time reduce impacts on interdependent systems, such as food supply and clean water and the environment.
Join us as we explore the beauty, the complexity, and the dynamics of this place we call home.